All right, welcome to Basic Math. We're going to be looking at adding and subtracting fractions today. So, 3 steps. First step, find a least common denominator. Now, I'm not going to show you how to find a least common denominator in this video. I have another video that does that, and so if you need help finding a least common denominator, go back and watch that other video. All right, find a least common denominator. Then we're going to multiply to change our fractions so they have that least common denominator. And then add or subtract. But only the numerators, only the top parts of the fraction get added together. All right, so let's take a look. Here we go. I have, well, let's get rid of this for a second. I have 3/4 plus 1/8. Okay, now I use the inspection method to find my least common denominator here, which is 8. Right? 8 is divisible by 8. 8 is divisible by 4. It works. It's my common denominator. So now I have to decide, okay, what do I need to change and what do I need to multiply to get to these denominators of 8? Well, the second fraction isn't going to change at all. It's already got an 8 on the bottom, so I don't have to change that one. But for the 3/4, I am going to have to change that. So I'm going to ask myself, 4 times what will give me 8? Now, this one's not too bad, it's just 2, right? 4 times 2 would be 8. But, here's the thing, if I don't know that it's 2, I can always just divide it. Take the 8 and divide by 4. 8 divided by 4 is 2, and that will tell me what to multiply by. Now, the other thing is, I'm not just multiplying the bottom. I'm also going to multiply the top. Okay, that way we get what are called equivalent fractions. 3/4 and then 2 times 3 is 6. 3/4 and 6/8, they're really fractions that represent the same amount. One easy way to see that is to draw yourself a picture of a pizza. Okay? Cut your pizza into 4 even parts and shade 3 of them. And then cut each of those pieces in half to make 8, and you'll see that the 6 out of 8 is exactly the same as the 3 out of 4. So anyway, now that I have a common denominator, I just add the numerators. Do not touch the denominators. They stay the way they are. 6 plus 1 is 7. I have my answer. It's just 7/8. All right, let's do another example. Let's pause. All right, my next example, 9/5 minus 1/2. 9/5 is, of course, an improper fraction, but that's okay. One thing to know is that we're going to do mixed numbers here in just a minute, but if you want, you can always change them into improper fractions to do the addition or subtraction. Some people find that to be a lot easier. All right, so for 5 and 2, my common denominator would be 10. Again, I'm just kind of staring at that one to figure it out. And a lot of times you can do that. So since my common denominator is 10, I need to rewrite these fractions with 10 on the bottom. So I need to know what do I multiply by to get there. Well, for 5, it's 5 times 2. So I'm multiplying the first fraction, top and bottom, by 2 to get to 18/10. 2 times 9 gives me 18. Now I have to do the same sort of thing over here for the 1/2. 2 times what is 10? Well, the answer is 5, so I'm going to multiply the top and the bottom by 5. 1 times 5 gives me 5/10. Now I can do my subtraction. Just like with the last problem, once you have that common denominator, you don't change it. Right? I keep my 10 as part of the answer. 18 minus 5 is 13, so I have an answer now of 13/10. If you needed to, you could write that then as a mixed number, but yeah, so there we go. All right, mixed numbers. Let's add these two things together. 4 1/3 and 5 1/6. So for starters, I'm going to treat this one just like I did with any other fraction. I'm going to find that common denominator. For 3 and 6, my common denominator is 6. Okay, I got that by just staring at it. Another inspection method problem. So to get there, I have to multiply the 1/3 by 2, right, to get to the 6. So I multiply both of those by 2 to get 2/6. But notice, I didn't change the whole numbers. I'm just messing around with the fractions here. Okay, so it's really not that bad. It's really the same thing as what we did back on this one, only now I have these whole numbers in front as well. Once we get here, this is really nice. I just add the whole numbers. 4 and 5 make 9, and then I add the fractions. So again, I only add the numerators. 2 plus 1 gives me 3. So I get 9 and 3/6. But then, of course, I can reduce 3 over 6 all the way down to 1/2. So make sure you do that. If you can, you need to reduce your fractions. All right, so let's do one more example. Why not? All right, so now I have a problem here with mixed numbers and subtraction. So this one's going to require us to borrow, and I'll show you that here in just a minute when we get to it. But it's worth pointing out we could have done this by turning these into improper fractions. The numbers here would really end up being quite large, but it could be done. And so sometimes a lot of people will really prefer to just turn them into improper fractions, do the subtraction, and then turn them back into mixed numbers. So I'm not going to show you that. You're welcome to mess around with that. But I'm going to do this with borrowing, so it's going to be interesting. So I have denominators of 15 and 20. My common denominator is 60. So I changed my fractions so that we had a common denominator of 60. 15 times 4 gives me 60, so I do the same thing on the top. 7 times 4 gives me 28. For 20 times 3 is 60, 13 times 3 gives me 39. Now, here's the problem. 8 minus 3 is a piece of cake, that's just 5, but hold on to that. Don't do that yet. Because here's where the problem really is. 28 minus 39 doesn't work. That subtraction is backwards. We don't want to have a negative fraction here. This would be really weird and not quite right. So what I'm going to do is I'm going to borrow. I want more pieces here for the 28. So I'm going to steal one from the 8. I'm going to rewrite this and turn it into a 7. But now, how many pieces are in one whole? Because that's what I just borrowed. I borrowed one whole. Well, the denominator always tells you how many pieces are in the whole. So I borrowed 60 pieces, and I'm going to add those on to my 28. And I bring the rest of the problem down, and it looks really strange, right? Because I added this whole onto that 28. I have 88 over 60, so I have this very goofy looking mixed number, but now I can do the subtraction. 88 minus 39 is, oh dear, I should have done this ahead of time. Let's see, 49. 88 minus 39 is 49. 7 minus 3 is 4. And now I look to see if I can reduce my fraction. I don't think I can, so it's done. So that's one option for dealing with these subtraction problems. Like I said, you also could have, turned these all into improper fractions. 15 times 8 would be 120. So plus 7, 127 over 15. And then 60, 73 over 20. And then you could have gone from there. So some people like to do it both ways, but that's how you would do it with borrowing. Just always remember, when you borrow, you're borrowing a whole, and that number will depend on what your denominator is. So there you go. There's adding and subtracting fractions. Good luck, and yeah, thanks for coming.